So our last topic here is solving systems of equations. And there's a few ways to solve most systems of equations. I'm going to try and do the easiest one for each of these setups here. So for this first one, what I see is I'm going to use a method where we add or subtract the two equations and try to cancel one of the variables. In this case, I'm going to try and cancel out the y. So what I'm going to do is I'm going to multiply this top equation, the whole thing, by 4, and I'm going to multiply this bottom equation, the whole thing, by 3. And why I'm doing that is then we'll have a negative 12y on top and a positive 12y in the bottom equation, and when we add them, the y's will cancel out. So what I'm going to get is 28x minus 12y is equal to 58 for my top equation, and then my bottom equation is going to become 6x plus 12y is going to be equal to 27. Now I'm going to add the entire equation here, and so what I end up getting is 34x. The y's cancel out there, and that's going to be equal to 85. I divide by 34, and I find that my x is going to be equal to 2.5. Once I know x, I can then use that in either equation to solve for y. So I'm going to go back here, and I'm going to just pick the second equation. And so I'm going to say 2x plus 4y equals 9. So 2 times 2.5 plus 4y equals 9. So 5 plus 4y equals 9. 4y then is going to be equal to 4 subtracting 5 from both sides, so then y is equal to 1. The nice thing about these types of problems is you could always double check this by plugging your x value and your y value into the other equation and seeing if it works. So I'm not always going to do this, but real quick I'll show you that. So we have 7 times 2.5, my x value, minus 3 times 1, my y value. Again, I'm just using this first equation here, equals 14.5. So I end up getting here that 17.5 minus 3 equals 14.5, and that is true. So that is probably a really good indication that you have the correct answer here. Moving on to my next one here, I'm going to use the same method as what I did in problem number 25, but I'm first going to rearrange that bottom equation. So I'm going to leave the top one the way it is, and I'm going to match up my variables so that I have x and y on the one side and any just numbers on the other side. So we're going to bring that 1/3 x over here, subtracting it from both sides, minus 4y, and that's going to be equal to 2. And what I immediately see here is if I multiply this equation here by 2, I'm going to be able to cancel out my y's once again. So I'm just going to write that down here. So I'm going to have 1x now plus 4y equals 2. So I'm going to be adding these two equations together. The y terms are going to go away, and what I'm left with is 2/3 x, negative 1/3 plus 1, is equal to 4. Okay, so then I'm either going to divide both sides by 2/3, or what you can actually do that's kind of nice is multiply by the reciprocal, 3/2. And that gets rid of the 2/3 here, and so what I'm left with is that x is equal to 6. I'm going to take that value now and plug it back into my top equation, so I take my 1/2 x plus 2y equals 1. So I'm going to say 1/2 times 6 plus 2y equals 1. So 3 plus 2y equals 1, which means that 2y is equal to negative 2. Dividing both sides by 2, I get that y is equal to negative 1. Once again, you could check your answer by plugging your x and y values into the bottom equation, but I'm not going to do that with this particular problem. So for this next one, we could use a method similar to what we've been doing before, but what I'm actually going to do, because what I see right off the bat is that we have two equations both equal to y. I'm going to use what's basically the substitution method, okay? And since both 4x plus 7 is equal to y and 2x minus 1 is equal to y, I'm going to simply set them equal to each other. So I have 4x plus 7 equals 2x minus 1. I'm going to subtract 2x from both sides, and I get 2x plus 7 equals negative 1. Which means that 2x is going to be equal to negative 8, so x here is equal to negative 4. Now that I have that x, I can use either equation once again and just substitute in that x value. So y equals 4 times negative 4 plus 7. Y is going to be equal to negative 16 plus 7, so y here is equal to negative 9. Moving on to our last problem here, I'm going to use the substitution method yet again, although that's not the only possible way to do this, but I see that y by itself here. So what I'm going to do is I'm going to rearrange this equation to solve for y. So I'm going to say 6 minus 2x is equal to y, bringing the 2x over to the left and the negative y over to the right. And then I'm going to take that and substitute that into the other equation, 4x plus 3y equals 12. So I'm going to say 4x plus 3 times 6 minus 2x, right? Because that's what y is equal to. And that's going to be equal to 12. I'm going to go and distribute that 3. So 4x plus 18 minus 6x, multiplying that 3 by both of those terms, is equal to 12. So we have negative 2x plus 18 equals 12. Negative 2x then is equal to negative 6. So x is equal to 3 in this case. Finishing this up, I'm going to take that bottom equation, 4x plus 3y equals 12. And I'm going to substitute in that x value, 4 times 3 plus 3y equals 12. So I get 12 plus 3y equals 12. So 3y is equal to 0, which means that y is simply equal to 0 in this case. Keep in mind I could have used the method where I'm adding or subtracting equations. That would have worked exactly the same. I just chose to use the substitution method. But if you were doing that, your setup would be, you would have first get the x's and y's by themselves, so that first equation would become 2x minus y equals 6. Second equation, 4x plus 3y equals 12. What I would probably do is multiply this by 3, okay, and then the y's would cancel out and you could solve it just the same. Another thing to keep in mind is, although I always ended up solving for x first here, there's absolutely nothing wrong with solving for y first. There's many ways to do these problems. I just showed you one possible way to do them.